Servo valve. First developed in the 1940s, the servo valves operate with very high accuracy, repeatability, and high-frequency response. Servo valves are highly responsive and capable of handling minuscule flow changes both rapidly and accurately over a broad range of flow rates, but at an extra cost. The main difference between proportional and servo valve circuit design is that servo systems have a method of feedback that assures that the actuator is doing what the controller tells it to do. Most industrial applications use feedback from electronic, linear, rotary, or force transducers. A transducer is a device that produces an electrical signal in direct relation to a position, force, or speed. These devices feed a precise position or speed indication back to an electronic controller via a feedback wire, which in turn adjusts the valve. Fluid from the pump inlet is tapped off through filter elements, passes through orifices past both ends of the spool, goes on to nozzles, and out to the return line. A feedback wire attached to the flapper terminates in a ball end that sits in a very close-fit slot in the spool. When the torque motor coils receive a current signal, the armature rotates clockwise or counterclockwise and pushes the flapper closer to one nozzle and farther away from the opposite one. This allows pressure to increase at one end of the spool and decrease at the other. The spool then starts to move away from the higher pressure. If the armature turns clockwise, pressure builds on the left end of the spool and it moves to the right. With these very accurate feedback devices and a fast response servo valve, an actuator's position, speed, and/or force can be repeatedly established within an extremely close range. Electronics provides the accuracy while hydraulics provides the force via a super responsive servo valve.